as we start to settle in, I'm just going to give it a couple more seconds for all of our participants to enter the chat. Welcome, and this is our Aeronautical Engineering webinar. It is July 22nd. I hope everyone's having a great summer so far. I am joined here, my name's Lauren Souter. I'm one of the Assistant Directors of Admissions here at Rensselaer, and you will be with us just for about an hour today, maybe a little over an hour depending on your questions. But just a few words of wisdom. Our Slate platform here is a moderated chat box, so if you do have questions, feel free to put those in the chat box. We will be approving those and answering those based on the flow of everything. If you have admissions related questions, it'll be me. And then our team, Kate and Fotis, will be answering kind of more program related questions as well. And we will have live question and answer at the end. Throughout, if we can answer your question in the chat, you'll see the answer there. So just kind of a flow. If you do have some audio issues, we have heard of folks needing to refresh their page. Google Chrome and Firefox are the preferred web browsers here for our platform today. We've heard feedback that Safari and Internet Explorer might not play as nice, just so you know. But yeah, without further ado, I will pass it over to our team here, and we'll be back with you with questions. Thank you.
Thanks, Lauren, and I will be back on with Lauren at the end too, and I'm going to just turn this over to Fotis to do the presentation.
Hello everyone. I'm very glad that I have this opportunity, and thank you, Kate and Lauren, for organizing this webinar. We're going to talk briefly about the program of the aeronautical engineering here at RPI in the mechanical, aeronautical, and nuclear engineering department. So my name is Fotis Kopsaftopoulos. First name is Fotis, just call me Fotis. As you, perhaps it's evident by my last name, I'm from Greece. I have this long last name that it's impossible to pronounce. I'm an assistant professor of aerospace engineering. I joined RPI in October 2017, so I'm in my third year at RPI. And I will make an effort to provide a brief overview of our program, and then we would be happy to answer to any questions that you might have as we move forward. So the goals of the webinar, first of all, we would like to introduce the program, the curriculum, and the faculty, the people at RPI. We're going to provide some high-level information about some of the activities related to classes, research, clubs at RPI, some high-level information about what does it mean to be an aeronautical or aerospace engineer, and we will be also answering your questions throughout the course of this presentation, but also later we're gonna open the floor with live questions. Now, initially, well, as the first thing, right, what aeronautical engineers do, right? What is that they do? And what are the main, let's say, topics of our work? Well, obviously, we work on airplanes, helicopters. Recently, there is this very interesting trend related to urban air mobility, flying cars, flying taxis. Probably you've heard about it all over the news. We're also working on submarines, hydrofoils, even boats, anything that might be related to the aerodynamics or structures. And these configurations are quite similar when we're talking about an airplane, a helicopter, a drone, a quadcopter, multicopter, even with boats and submarines like America Cup boats. There are so many common aspects. So essentially, these are some of the very interesting parts of our work. We're also working to topics related to space, from rockets and lunar landers, Mars rover satellites, CubeSats, which is recently there's a great interest in the development and analysis of CubeSats, minor, very small satellites that can be in orbit, and they can be in orbit for several years, and they can perform different operations. And also we're interested in the analysis and development of engines, high-speed trains, wind turbines, and let me add also topics related to bridges and even smart buildings that pertain to civil infrastructures. So essentially, as long as we have some kind of aerodynamics and the physics of the aerodynamics, as well as the physics of structures, and then the third aspect, the knowledge of systems and signals and data, all these comprise some of the main topics that aeronautical engineers work both in industry, national labs, academia, and so on and so forth. Now, some of the main aeronautical aerospace engineering disciplines include fixed-wing aircraft or rotary-wing aircraft. Fixed-wing aircraft, this can be a very broad topic. So imagine a Boeing 747, an Airbus 350, or it could be a Cessna 182. It can be an F-35, an F-16. It can be a solar UAV, both manned and unmanned aircraft, or even small fixed-wing UAVs, similar to the ones that some of you perhaps you have experience with RC flying, remote-controlled aircraft made out of foam that you can find in hobby stores. We're also interested in rotary-wing aircraft. This means helicopters, drones, multicopters, and there are so many interesting technologies, as I did mention before, related to the topic of urban air mobility that also essentially are driven by the development of novel rotary wing designs and aircraft. Another aspect is related to propulsion for both aircraft and spacecraft systems and structures. We're also working on lightweight structures and adaptive smart structures, where essentially we're trying to build the next generation of lightweight. This means that we're trying to decrease, obviously, the weight, but at the same time, we're trying to maintain the structural properties of the aircraft. So we don't want to have a lightweight aircraft that is very prone to damage or structural issues and failures. And at the same time, we're trying to develop and design novel adaptive or smart structures. So imagine, similar to the way that birds fly, where they shape their wings in real time so that they can guide their flight, imagine such concepts applied to aircraft. So we can have a wing that can change its shape in real time, and based on that, it can guide and it can optimize the performance during flight. We're also working on flight control systems and avionics, so it's critical that we devise control schemes based on which we can perform the guidance, navigation of aircraft. At the same time, we're trying to develop approaches and algorithms based on which we can detect, analyze faults that may occur in different systems of the aircraft, in the avionics, in the sensors, in the actuators, in the engines, even in the structures. We're also working on the fluid mechanics and heat transfer from the very basics of the analysis of the physics, how the fluids will develop, what are the main underlying phenomena that are related to the fluid mechanics pertaining, again, to aeronautical and aerospace systems. And also we're working on high-performance computing. And this is related to also to the data analytics, data-driven approaches, machine learning, and so on. So essentially, we need to be able to perform very fast the computations we need so that we can analyze both the data that we're recording during flight, historical data, but at the same time, where we're performing different types of simulations, we're interested in doing this in a manner that is efficient in terms of the computational time and computational cost that we have to face. So the graduates, when they go and when they leave RPI, here are some indicative options. I'm talking about the third aspect. Graduates typically choose industry or government laboratory careers. Also, some of the graduates, they continue with a co-term master's program or a PhD program here at RPI or other universities. And again, the topics or like the careers that someone could follow are related to, I would say, to three high-level areas, perhaps four. One is related to aerodynamics. We can work on high-speed or even lower-speed aerodynamics, but essentially the aerodynamics is the underarching topic. And this is related to the design and the analysis of the aerodynamics, of the shape of the aircraft, of the airfoils, of the wings, of the fuselage, on the way that we can have different motors or rotor systems on the engines and so on, pertaining to the aerodynamics. The second aspect is related to the structural topic. So we can design the actual structures of aerospace systems. How can we design a wing that is not heavy, but it's lightweight, but at the same time, it has the structural properties that we desire? Or how can we design a wing that can change its shape, as I mentioned before, in real time? We're also working on the control. This is a third major category. So how can we devise controllers and navigation systems that can be used to existing, but also to new aircraft and novel aircraft designs? And there are many different focal points of interest, depending on the type of industry or the government lab or school you will be joining. Once you graduate, there are so many different opportunities. And this is one of the very interesting parts of being an aeronautical engineer, because essentially there is an infinite number of options that someone can choose from. And when it comes to industry, usually graduates, they go and work for major companies like Boeing, Lockheed Martin, Northrop, Sikorsky, Bell. Even oftentimes they go and work in companies like Uber, Google, Apple, and so on. At the same time, if someone is interested more into joining a government lab, there are many opportunities. Usually we have several internships in national labs, with the Air Force, with the Navy, with the Army as well. And the third career path that someone may pursue is advanced graduate level studies that can lead to in-depth knowledge and analysis of specific focal points of interest. Now, this is a generic overview. Well, first, we have to talk about the actual curriculum, right? This is the most significant aspect. And as you know, it's 8 semesters. Now, in the first year, let me go briefly through some of the main aspects of the curriculum. In the first year, as you can see in the fall semester and the spring semester, most of the classes are related to basic math and sciences. So from calculus, physics, engineering, graphics, using computer-aided design, CAD, introduction to engineering analysis. So these are the main courses that you would have to take in the first year, during the first 2 semesters. And this might not be related, it's not evident that they're related to the core aero discipline, but at the same time, let me pinpoint that it's very, very significant for each one of you to develop a solid math and sciences background and base. Because then everything becomes so much easier. And that was my personal experience when I was doing my undergrad. I'm from Greece, I did it in Greece, and I had a very good background in math from high school, and then I continued and I developed my math background. So when I started working and taking classes related to the core disciplines of an aeronautical aerospace engineering, I found that these classes were so much easier because I was able to decode what I was learning because I had a very good background in calculus and physics and math in general. So the first year is critical, and this is also my experience here at RPI, that the students are able to perform well and put the time and the effort in these classes, then they won't have any issues or they won't have to face any significant challenges when it comes to the understanding of courses related to the aero discipline. Now, in the second year, we're getting into core engineering science-related topics. So we start with strength of materials, where you will be able to learn the basic aspects of the materials, thermodynamics, some additional courses related to math, like differential equations, and the way that they can be applied to our own aero discipline or even mechanical disciplines. There is a very interesting course in the spring semester, which is related to the modeling and analysis of uncertainty. And this is, again, this will help you to understand better some of the remaining subsequent topics. And also numerical methods, programming, fluid mechanics, and there are some electives that you are able to take within the first 4 semesters. Now, what you may observe is that each course has a different amount of credit units. And this, I mean, we can talk about it later perhaps, or if you have any specific questions, but this essentially gives you an idea of the time commitment that, or the significance of the course related to the discipline. And this also obviously will affect in a different way the way that your GPA will be calculated at the end. This is high-level overview. I won't provide any additional details, but I would be happy to answer the questions as we move forward. Now, in the third year, you will start getting into the more, I would say, interesting topics related to the aero discipline. And some of them are related to the dynamics. This could also be taken in the second year. There is some kind of flexibility. But essentially, we have the 3 major courses that I think are the most significant, and I would say representative. Not significant in terms of all the courses are significant, but representative of some of the potential career paths that you may have to follow once you graduate. So one course is related to the aerospace structures and materials. the other one is Aerodynamics, and the third one is Modeling and Control of Dynamical Systems. So these 3 courses will provide you an idea, and depending on what is your preference, you can see yourself working as an aerospace structural engineer, or like a person who designs an aircraft based on the aerodynamics, or someone who will be doing the modeling using data and signals and devising control frameworks and how we can guide and control the aircraft. And then there are more specialized courses of interest. There are some laboratories, Fluid Dynamics Lab, Aerospace Structures and Controls Lab, and also some free electives. And also in the final year, you will continue to get into more depth in some of these courses. Again, propulsion systems, there are more electives in the final year, so you have the options to decide based on your interests and your preferences. You would be able to decide and choose some courses that would be a good match for you. Now, throughout the curriculum, we're trying to integrate some of these ideas, right? So we're trying to make the connections between the different courses throughout the different years of study so that you can get also a high-level idea. It might be common that in the first year you won't have, as I mentioned before, like a very good idea of the core aerodiscipline courses, but at the same time, this should not be a discouraging factor because this will happen very, very fast. And again, the aim should be for you to build a very good background when it comes to the math and physics, so everything will flow very smoothly in the subsequent years. Now, in total, you would have to complete 130 credits, and then you will be able to graduate. Now, these credits, depending on the type of courses, are divided into different classes. So you have to take 22 credits from humanities, arts, and social sciences related topics. So this corresponds to probably 5 courses, electives, and there are different pathways that you can decide. And there is additional info that we can discuss again a bit later. Now, 28 credits are related to the math and science core courses. 18 credits are related to the core engineering topics, and 50 credits are related to aerospace engineering courses. Okay, and also you have 12 courses, 12 credits that can be used as free electives. So it's up to you to decide what courses to take, again, depending on your interests. So this is the breakdown. You can find more info using the links that we have provided. You can find more info also on the website where we have the catalog of the courses, more details, and also feel free to ask questions or even email us about additional info that you might need. Now, one of the initial questions is, okay, why as aerospace or aeronautical engineers do we have to take humanities, arts, and social sciences courses? And I think the answer to me is somewhat evident, right? Because we would like to develop high quality, amazing engineering students, but at the same time, we have to take care of our personal development as well. And these courses are related, obviously, to the communication. So we're trying to develop communication skills, both oral and writing skills. They're related to leadership courses, collaboration, and this will try to promote and develop your creativity, global view, and ethics. And there is a big diversity with respect to the courses that you're able to take. It would be up to you to choose what types of classes. So if someone would like to take a class related to philosophy, there you can find these courses, or psychology, or perhaps improvement of oral communication. Again, you can find more info on the website. And well, let me complete the description of this slide and say that, again, you will have to take probably 5 courses, and there are different pathways depending on your interest that you can define, and you can make a plan on which course you would like to take. Now, the second category is related to the math and science classes. This is 28 credits. So these courses are related to foundational skills for engineering. So problem solving, critical thinking, research skills. And also in some of the courses, you can also apply your AP credits or transfer credits that you have from high school or from other schools if you are a transfer student. Again, we can provide additional info. If you have any questions, let us know. Kate and Lauren will be able to provide more specific info at least when it comes to the AP and transfer credit. Again, let me emphasize that these courses are critical to your subsequent years at RPI. Even though they may not seem that they're directly related, they will make the transition to the core classes much, much easier, okay? And there is also the opportunity for you to build your background as you move forward. Now, the third category is related to the core engineering classes. So these classes could be common to a mechanical, aero engineer, even electrical, biomedical engineer, and they're related to the dynamics, mechanics, materials, design, data and statistics, even manufacturing and CAD. You can declare your major. In this case, it seems obviously that you're interested in the aeronautical engineering. Some of these courses are shared with the other majors. Yeah, I think that summarizes the core engineering classes. Most of these classes will take place in the second year. So in the sophomore year, and perhaps some of them in the junior, or some of them even in the freshman year, depending on the additional credits that you might have from AP or transfer credits. Now, the aeronautical engineering classes hold the majority of the credits, so these are equivalent to 50 credits. So the first class you will have to take is related to the fundamentals of flight, and this class is in the first semester. No, it's in the second semester of your first year at RPI. And in this class, essentially, we're going to have probably 10 or 12 presentations from RPI professors, and each one will describe his or her work, research area, along with the relationship with industry or even grad school and so on and so forth. So this is going to be a very good overview, initial overview of some of the topics that you will be addressing during your studies at RPI. Some additional courses are related to numerical methods and programming. So this is critical. I cannot emphasize it enough. Once you graduate, you can see, I think it is evident that each one of you will have to develop some kind of programming knowledge or programming skills or numerical methods. It is critical. So you've seen that where everyone is talking about data sciences, machine learning, statistics. So this course will be an introductory course on how you can program, how you can develop some basic skills using MATLAB or Python or C++. There are additional classes that you are able to take if these topics fall within your interests. But this is something that, again, I cannot emphasize enough, especially when it comes to the use of MATLAB and Python in our curriculum. Then we have additional courses related to thermodynamics, fluid mechanics, aerodynamics, again, critical courses for an aeronautical engineer, aerospace structural materials, propulsion systems, aeroelasticity, structural vibrations, and modeling and control of dynamical systems. I would say these are the major classes, core classes that you would have to take. And also we have 3 labs, the fluid dynamics, aerospace structures, and control systems lab. Now, there are also different electives that you are able to take. You have 12 credits as electives. And one category related to electives is the computational topic. So in this case, you will learn, if you are interested in this category, you will learn how to perform some analysis and simulation and design methods using computational tools. So in the case of structures, the major tool that we're interested in, it's required by the industry. If you would like to work, let's say, as a structural engineer with Boeing or with Sikorsky, you would have to know how to perform a finite element analysis framework. Or if you would like to work as an aerospace aerodynamics engineer, you would have to know how to perform computational fluid dynamics analysis. And also, we have the design optimization. So we offer courses that are tailored to these topics. Oftentimes, they're combined with projects. And I would have to say these are very, very interesting topics. Well, you'd have to be patient, though, because it's going to take you some time until you get to that point. And also, we have flight mechanics elective, so you can learn about the flight mechanics of rotary wing, fixed wing, or space aircraft, spacecraft. And also there's the capstone design. Again, we have the separation into the three classes: rotor, fixed wing, or space. And let me say that when it comes to the rotary wing, at RPI we have a new center that was established like 1.5 years ago. So we call it Center for Mobility with Vertical Lift. So there is a team of professors. The center is directed by Professor Farhan Gandhi, and we're working on topics related to helicopters, urban air mobility, drones, anything related to vertical takeoff and landing systems. And this is why we have, again, so many courses related to drones and helicopters and rotary wing. Now, well, the free electives, you also have 12 credits. You can do whatever you want with these credits. You can take any classes you would like. Let me also mention at this point that you can also perform undergraduate research. So you can perform undergraduate research and you can get credit. So you can get 3, 4, or 2 credit units depending on your preference. And this is a great opportunity if you would like to dive a bit deeper and see how research is being performed. We're talking about world-class research in our program. And oftentimes students, they are able to publish some of these results. They collaborate with graduate students, PhD students. So this is a great opportunity for anyone who would like to dive a bit deeper into some of these topics. And also you can use these free elective credits to pursue dual majors. A very common dual major is between aero and mechanical program, or electrical engineering, computer science, data science. So there is also this possibility. Now, well, outside classroom, RPI is not only about the classes, but also there are so many, like several activities outside class. First of all, there are so many like extracurricular clubs and academic as well. Now, the ones that are of interest to the aerospace program are related to the design, build, and fly. So this club is very, very popular. There are many students involved. It has a very solid structure. It has a very good historical approach to the way that it works. So the students, there is a nice sequence of students being involved in this club, and they have to design, build, and fly an aircraft. And this is related to a competition that is being announced every year. So you can be involved as early as you want, as you make friends, as you get your networking here at RPI. You will learn more about this club. Feel free to reach out any mail, the president or like the members of this club. Oftentimes, some of these activities are also related to the research we're doing as well. There's a Rocket Society, there's the Space Flight Society, the Drone Club. The Drone Club, I think it's new. It started probably 2 years ago. Again, all kinds of drone designs, quadcopters, multicopters, flying RC aircraft, everything. There is a Forge Maker Group. So if you're interested in building, designing, and making aircraft or like helicopters, drones, this is something that would be of interest to you. Embedded hardware, if you're interested more into the hardware and the computational aspect, robotics, motorsports. So this is like, there is an infinite number of like amount of opportunities depending on your time. And at this point, let me make one like brief parenthesis and talk about time. Time management is probably the most significant and essential skill you have to develop as students at any university, but here at RPI as well. And time management is going to be critical. It's going to remove lots of the stress that you might have as you will be tackling new challenges and new topics, new classes. But at the same time, it will make everything easier. And this skill, obviously, you will have to think about it. You will have to organize your time. You will have to prioritize your activities. And this is something that you learn how to develop as you move forward in your student careers. Also, there are several co-op and internship opportunities, and there is also the Arts Away semester. Okay. Now, let me again provide a very brief overview of the RPI Aero faculty. These have been classified with respect to the topics that each professor is dealing with in his or her research area. So we have Aerodynamics, Fluids, and Design. So we have Professor Miki Amite, who is also the director of the Center of Flow Physics and Control. He's an experimental guy. His work has been supported by Boeing, by the Air Force, by NSF. So he's doing amazing research. His topics are so interesting. He has many, many students. Both undergraduate students are working with Professor Amite, graduate students, all levels. In the center of Professor Amite, the Aero department, we have several wind tunnels available. So we have, I think, 5 wind tunnels that students can use, undergraduate students can use. So if you would like to design something, you have to reach out, and then you can design your own aircraft, your small drone UAV, and you can go and you can make some experiments in the wind tunnel, and we would be happy to support you. There is Professor Amir Hirsa. He is also an experimental hydrodynamics professor. Chia Leong and Keith Taylor, they're also working on aerodynamics. From the computational side, we have Professor Jason Hicken. He's working mostly on the multidisciplinary design optimization. So multidisciplinary, it means that we're trying to optimize the design of an aircraft when we take into account different disciplines. So we're trying to optimize the design with respect to the aerodynamics, with respect to the structural response, with respect to some of the constraints that we might have, even the manufacturing constraints, cost constraints. So Professor Hicken has been working on these topics for several years. He's the recipient of the Young Investigator Award from the Air Force and the National Science Foundation. The same with Professor Onkar Sani. Professor Sani, he has been working on computational fluid dynamics for many years. They have very interesting topics that they tackle within their groups. And I would say these are the professors and faculty working on the aerodynamics and fluids design aspect. Now, we have Professor Kurt Anderson and John Christian. They are the space experts of RPI. So if you're interested into space-related topics, you will take many courses with Professor Anderson and Christian. Professor Anderson is working mostly on the dynamics side, and Professor Christian is working on the navigation and control aspect of space, satellites, spacecraft, and so on and so forth. We have the propulsion expert, Professor Matt Oeschlager, and also we have the structures, materials, and control topic. We have Professor Farhan Gandhi. He is an expert in helicopters, rotary wing, myself, and we also have Professor Nikhil Koratkar. So he's an expert when it comes to smart materials, advanced materials, composite materials, and so on and so forth. Okay, so this is a very brief overview. Unfortunately, we do not have too much time to go through this, but we would be happy to provide more info. Feel free to check the website of Maine. You can find the links of the websites of the different groups and labs, info on the projects and the research we're doing, on the collaborations we have with industry and academia and even government labs and agencies. So you can find lots of info, and feel free also to reach out in your questions or in using email communication. And also we have advising resources for students. Kate, Julie, and Tom, they're amazing. We work with them every day. Kate is here, so she will be able also to respond to your questions. And I think, let me wrap up this presentation by saying that, okay, RPI, the department is not huge. And one of the great things is that you will have the chance to meet with faculty, with staff, with everyone. So this is one of the great things that I appreciated when I joined RPI. It's a very warm atmosphere, it's a very warm environment, and everyone is very friendly and everyone is very willing to contribute to your development, help in any way that we can, and obviously answer questions or provide additional info. Okay, so let me stop here, and we would be happy to take any questions that you might have.
All right, great. Thank you all for the great questions coming in so far. Kind of just start at the top here. So we have a question about actually 2 folks wondering about NASA. I know you have a partnership with NASA on campus. Do you have internship connections with them? Are there internship opportunities with commercial space companies such as SpaceX, ULA,
when it comes to
etc.?
NASA, there are several internship opportunities. This could depend on the topic of interest, because NASA has different, it's a very broad agency, so there are different topics of interest that the NASA is trying to promote, and this depends on the year. It depends, obviously, on the topics that are being defined by the strategic plan of NASA. There are many opportunities. As far as I know, at least when it comes to the ones that I know with my group, we have many opportunities with the Air Force Research Lab, with the Army, and with the Navy. So it is very easy to reach out if there is some interest. Usually there is a formal application process, so the students have to submit their resumes with some transcripts, some recommendation letters, but there is a personal interaction with many of these agencies, because these agencies, they're also funding our research topics. And then it is easier for us if there are motivated students who have shown the interest to write a very good letter and then promote them in terms of finding an internship or a co-op with NASA. When it comes to companies, again, there are many opportunities. I think RPI has a website, and there is a specific website that these opportunities are being posted. But at the same time, again, when we collaborate with industrial partners, right? So oftentimes we receive an email that someone is looking for a good student or an interested, motivated student to work on some topics. Yes, so I would say there are many opportunities. So it would be up to you to, yeah.
Great, great. And yes, someone was wondering, in the past year, have any RPI graduates
So I will talk about my students who graduated.
This past year that you remember?
One went to Boeing, another one, I think, Sikorsky. Most of the students, undergraduate students that I know, and they're doing research within my group, they continued to graduate level studies. Some of them, they stayed at RPI. I know one went to Stanford, MIT, Cornell, Carnegie Mellon. So you have all these opportunities, right? So yeah.
Great, great. Someone asked about NASA in Virginia. Have you worked with them in the past or seen anyone go there?
3 years ago, we developed a smart wing with composite materials, and we did some experiments in a wind tunnel. Yes, so the answer is yes.
Great. Thank you. Next question. What are some examples of aeronautical engineering capstone projects
I think there is a list now from the topics that I know. I have a brief idea. Some of them are related to the design. One team that they had an interesting project related to the design of a UAV that has a pick and place mechanism. So the idea was that they would design a UAV, a small quadcopter, that is able to pick a small bag, grocery bag, and place it somewhere else. So that was one of the topics that I find interesting. Again, there are many topics. I was involved in that topic. This is what I know. This way I know it. Yeah, so.
Great, great. Easier one. How many people are enrolled in the aeronautical engineering major?
Oh, I'll take that one. So I think I did include this in an earlier one. Somebody wanted to know the difference between mechanical and aero, but typically it's about, it kind of varies year to year, but it's around half. So half of, so we have around 880 mechanical undergraduates and around 430 aero undergraduates. But again, that number kind of fluctuates, and a lot of times it fluctuates based on what's going on in the world and what's hot in the news, and then that incoming class sometimes is more mechanical or more aero. So, but right around half of our, half the amount of mechanicals to aero students.
Great, great. A few students wondering, just common minors that aero students participate in on campus. Do you recommend a minor?
I can answer that one too. And Fotis, if you have something to add, definitely add that, because you work with students on a small, like you have your own advisees, but on a typical typical day, I'll get students that ask about minors a lot, and minors are really good for a student's own interests. But sometimes students want something that's going to help them. So sometimes they think that, if they do a management minor, that'll help them based on what their career aspirations are. It's really easy. And I don't mean the classes are easy, but in terms of how to fit it into your degree, to do a minor in any of our HOS majors. So something like psychology or economics. I'm trying to think, SDSH, like anything that's more like of a general kind of social science type thing, or humanities, writing, that sort of thing, because you can fit it into what is required for your HOS requirements, and then it's usually just one more class. So those are the typical ones. Sometimes students will do a computer science minor. So that one's popular too. And yeah, we do. The only minor we have in Maine is nuclear. So we don't get a lot of students, but students could easily do a nuclear minor if they had an interest in it.
Fantastic. And it's funny, we got two of the same exact question. Have you seen a dual degree with aerospace and physics?
I'm sure we do. We don't get that often because that crosses two different schools. So it's a little trickier to get it all in, especially within 4 years. Right. For that, we definitely work with the students to try to put something together that's realistic. We encourage students to express that interest early on so we can try to make it work within the 4 years. Or if it's not possible, or if a student doesn't think about it until later on, we can usually steer them in another direction that might be a little bit more cost effective than trying to spend like 5 years on one bachelor's degree, or even though you get it in both areas, there's other ways you could either do a minor, or you could do research in another area and just do the one major, or you could do a co-term program either in physics or in aero and do your undergrad in the other. So there's other options, and that's why the advising aspect is very important at RPI. We want students to make good decisions based on good information.
Absolutely. Yeah. And someone had asked about the 5-year program. So yes, we do have a co-terminal program at RPI where you can tack on a 5th year and get your MS in a discipline that doesn't have to be what you majored in for your undergraduate level. So the 5-year master's program is called co-terminal, and it's very common here at RPI. As you map out your 4 years, think about that. You're out of here in 5 years with a BS and an MS. So that could be something great to consider when you're considering Rensselaer. Okay, so a couple of questions just about are there opportunities for study abroad as an aerospace or aeronautical engineering major?
So there's a couple ways you could do this. One thing is that you could do a lot of classes that weren't, so if you had an interest in traveling in a specific country and you wanted to take some of your classes that were part of your degree during that semester that you're traveling, you could do that. It may be harder to find specific engineering and definitely specific aeronautical or aerospace classes in that semester, but as you saw in the earlier slides, there are a lot of requirements that are not specific to engineering or specifically aeronautical. So you could just wait to take those classes, the more general classes, till that study abroad semester. So that's one way you could do it. We do have some affiliations with specific engineering institutions around the world. So that would narrow your options in terms of where you are traveling to. But, you could definitely do that too. So there's a couple different ways to do it. I'd encourage students that were interested in study abroad to check out our study abroad website. I'll try and find the link and put it in there, because that would give you a good idea of what, like, the variety of places students travel. And then again, you work with your advisor to make sure that it's all planned out so that you have enough credits in that semester, but that you're also not taking too many credits in that semester, so that you can enjoy yourself while you're traveling as well.
Yeah, great. And I actually just did this. Just can someone speak between the difference between aeronautical and aerospace and how that happens at RPI?
Sure, Fotis, you want to do that one?
Well, aeronautical and aerospace. Aerospace is a bit more generic, I have to say. Aerospace involves the space part as well as the aero part. Aeronautical essentially, it does not exclude, but it focuses mostly on the aero side of things. I think this is a major difference. Usually when it comes to schools or even the industry, we're using these words within the same context. Right? So it's the aerospace program or the aeronautical program. I think it's more about the terminology aspect. At this point, if someone is talking about aeronautical, it's quite broad, so space disciplines are also fall within this category.
Great. Trying to get related questions grouped together here.
So the other thing, the difference between the two, that the question that comes up a lot is that why does it, so we have a lot of students that really want that space designation, or they wanted to say it on their degree. Our degree is the aeronautical engineering degree, but we're working on getting that as part of to get the aerospace designation. Nothing will change with our curriculum. It's just the track students choose. So if they take the space flight mechanics and the space vehicle design, so nothing will change with the getting the approval. It's just that once it gets through, I think it's sitting on someone's desk, the last I heard, in somewhere in the state, then we'll be able to be approved to say that you have an aerospace degree. But again, it's the same exact degree. It's just somebody
the courses
getting
are
it
in
through
place.
the pipeline. Yep.
Great. And a couple questions just about what sort of research internship opportunities do aeronautical engineering students typically take? Either summer or
research
semester,
opportunities.
Things like that.
Well,
research.
Students may stay at RPI. There are several students who perform research with some of the groups. I have several undergraduate students each semester. Kate knows about it because I'm a big burden when it comes to the logistics. There are several students. Students also go, I know some of my students this semester, I think one at Boeing, one in a company that is doing turbine blades for engines in Florida. Another one, let me see, I think Aurora Flight Sciences. So there are many opportunities, right? So we cannot kind of have a short list of the opportunities. And again, well, by talking to the students, sometimes the internships are not what the students expect. It's not very common, but oftentimes, you may have an idea of what you will be doing, right? But this might not be the case. But this is very, very significant at the same time, because this will show how a company works, what is like the company environment, what are some of the main tasks that you will be doing, you will performing. So this experience is also very significant because it will help you decide the best steps for your professional career.
Great, thank you. And let's see, so someone, William Fotis, wants you to just speak a little more on your Smart Wing project that you did. Sorry, this was from before. If you just have any more details about that awesome Smart Wing project.
We do not have the time though. So, well, what we're trying to do is develop wing designs or aircraft designs that, well, think about the way that birds fly. Right? The birds, they can sense what is going on using the feathers they have on their wings. They have different types of sensors, the feathers, some sensors on their wings, they're called Mechanoreceptors. So based on these sensing capabilities, they know exactly what is the airflow, the aerodynamic properties, they know what are the loads, the moments, the vibrations on their wings, and this is how they guide the flight. So when we're talking about smart wings or intelligent wings, we're trying to learn from the way that birds fly, and we're trying to apply this knowledge to the way that aircraft fly. So we have a wing, usually made of composite materials. We put some sensors inside. We integrate sensors, small sensors that they do not compromise the mechanical properties. They do not cause any damages or structural integrity issues. And then we're collecting the data, and we're trying to analyze the data similar to the way that a bird analyzes its data. And based on that, we're trying to develop what we call state awareness. So we're trying to make an aircraft that is self-aware of its environment, its operation, its loads, its flight status, and so on. So this is a very high-level overview. There are a bunch of different challenges that we're trying to tackle. But yeah, this is in brief.
Awesome. Awesome. Great. And could either of you just comment on class size as related to aeronautical classes?
So I think it's going to depend on what class it is and what level you're at. So typically, and this goes for every major pretty much, once you get to senior year, you're going to probably have your smallest classes because they're going to be very specific and you're going to be in class mostly with just people who are sharing your major. Earlier on, you're going to take classes that are going to be a little bit larger. Everybody has to take, Calc 1, Physics 1, chemistry, those types of things. But for the aero classes, some of them, and it depends on the nature of the class, if the material is all lecture based, it may be a little bit bigger because a teaching load of teaching everybody just a lecture style just makes most sense to be a larger class. But some of our classes are very specific to hands-on learning, specific labs like our fluid dynamics lab, which is very small. It's actually pretty unique for this lab that we have. It's only used by undergraduates, so it's a class you'll take. Everybody takes it. Everybody goes into the lab. Everybody does experiments in there. It's one of the highlights usually when we have students on campus. They want to see the wind tunnel. So it's kind of a fun, exciting class. And so there's only 10 people, usually 10 to 11 people in those classes. And at a time, it's even less because they kind of split up the groups. So yeah, I mean, we love the answer. It depends, but basically,
I can provide more info about the class I'm teaching, which is the Aerospace Structures and Materials, which is one of the core classes. So this class, now with the summer arts, the classes are smaller. So in the fall, we had, or like throughout the year, we had classes with, the smallest class was 20-something students. The biggest one was 60. I would say the same applies to aerodynamics, and I think these are the larger classes in the aeronautical engineering program. Okay, and there might be modeling and control of dynamical systems that can be bigger class because it's common within both the aero and mechanical engineering programs. Okay, so more students take that class.
Great, great. And still in regard to scheduling, are students generally able to get the classes they want, for the semesters, that they're supposed to?
So that's part of what my job is that especially for Maine students, we work very closely with them. We, try to accommodate them with a wait list. The wait list isn't necessarily first come, first serve, although that's definitely an important part of it. We try to make sure students who need a class to graduate get in. So, we definitely will help students, and it's not all automated. It's not all, run through the system. Our goal is to get students to graduate and to get their degrees. So we do what we can to accommodate that. So yeah, I would say yes, they get the classes they need, and we've got people to help them make sure that happens.
Awesome. Great. And question from someone, I can shed a little light on this. Who are your top recruiters for summer internships, permanent jobs? First of all, the CCPD, the Career Center here at RPI, does post hiring statistics for every single major, so not just aeronautical. If you Google CCPD RPI and scroll down on the right-hand side of the page, there's a red link that says hiring statistics. So that's kind of general. I know we kind of talked about recruitment before, but would either of you just like to say, top recruiters off the top of your head for those who may have missed it earlier?
As far as I know, we have many students who go for internships at Sikorsky. And this is related to the mobility, to the Center for Mobility with Vertical Lift. We have many students who work, and we have some external research projects with the vertical lift research of excellence. So many students go and work with Sikorsky or with the Army or the Air Force related to topics of vertical lift, drones, helicopters, multi-copters. So I would say this is the major one. Yeah.
So Yeah, so we do a survey every year, and so I'm just looking at this past year, and I'll just read off a couple of different companies because there's a lot. But for our aero students, NASA Jet Propulsion, Space Systems, Laurel, U.S. Naval Air Command, Boeing, Raytheon, General Dynamics Electric Boat, Lockheed Martin, Becton, Pratt and Whitney. So that's just some of them, but there's a lot.
Great, great. Someone's asking for me, outside of these questions, you offer financial aid to international students. We actually do not, unfortunately. So the financial aid is just for domestic students, just due to the constraints with government and institutional aid. So unfortunately, the answer to that is no. Someone asked, if I major in aeronautical, am I applying to the school, the engineering program, or the specific major? Great question. So you can apply to RPI as an undecided engineer. So if you're, not quite sure, if you're engineering minded, but you're not quite sure which path, you can do engineering undecided. We see about 20% of students apply that way, or you could apply directly into your major. So aeronautical engineering. A third option, if you're like, hey, I love RPI, no idea what I want to do, you can apply undeclared to RPI just as a whole. We recommend to apply as specifically as possible. So if you're, really gung-ho on aeronautical, definitely apply to aeronautical because we want to get you in those classes your first semester, as specific as possible. But we do see about 20% of students applying undeclared engineering, undeclared School of Science, and that is very common as well. And test scores. So for this upcoming cycle, we are going to be standardized test optional. So you do not have to send your test scores for this upcoming cycle. In previous years for SAT, the average is about a 1320 to 1500, and ACT was a 29 to 33. So that's the range, that's the middle 50%. Some students fall above that and some students fall below. It is a very holistic process when it comes to admissions review. All right.
Yeah.
Sorry, just kind of multitasking here. Lots of great questions. Someone's asking, how flexible is class scheduling if you plan to play a sport? I know, coaches are really aware of the rigor of RPI. Do either of you have any other comments about, athletics and students having any trouble scheduling?
So I know that athletes usually get preferential time tickets, which is the time ticket is the time that students are able to register. So it's kind of on a rank system based on how many credits you have. The higher your credits, usually that means you're like a junior or senior if you have the highest credits. So you're going to get to register before the underclassmen. It's a little, so that's how it works typically for students that are returning for the next year that are already here. And then athletes usually come a little bit earlier than that. And then I'm trying to think if there's another group that's also early, but usually sometimes there's a test group that tests it out and they get to register early. So the athletes definitely, just because of their schedules, do get to get that little heads up and register early. And then again, depending on if it's a main class, they could work with me to see if there's room in some of our other classes. We hold seats to some extent because we know that sometimes we're going to get transfers that need those seats, or last minute students that realize they have a class they need and they need it to graduate. So there's some flexibility there. And I think all the departments kind of work a little differently, but they also can accommodate students for their schedules too.
Great. Thanks for shedding light on that. Someone's asking, I know we talked about course selection earlier. How would the required courses of a minor fit in with or alter the
So your major is always the most
four-year
important thing.
plan?
So you got to work around that. And usually in your schedule, if you look at a template, it'll leave room for a Haas class or a free elective class. So a lot of times your minors are going to fit into those spots. So if you're doing, like, for example, a psychology minor, then one of your Haas classes in that template for that semester can be towards your minor, or a free elective can work towards your minor. So so that's how they fit in. And then if it's going to go beyond the amount of credits, so like we talked about 12 credits for free electives, so it really for 4 credit classes only gives you 3, and most of our minors are 4 classes. Sometimes students have to fit in an extra class in one of their semesters to complete their minor. But we always want students to kind of work their minor around their major, so that if something has to go, it's not your major. You can graduate. That's the most important thing.
Gotcha. Someone asked another specific question. Do students ever feel that aeronautical engineering is too specific? Would a dual major with mechanical engineering fix this? So maybe, if someone only has their major in aeronautical, in the job world, would a dual major really come in handy? Does it make your prospects that much better?
Do you want to answer it? And then I can give the Tom answer.
Please, Kate. Yeah, feel free.
So Tom Haley is our Director of Undergraduate Student Services. He's also a faculty member, and he's worked at RPI, and he attended RPI. So he's been around for a long time at RPI. And it's going to be on both ends. Sometimes getting a dual degree, it definitely opens up some opportunities for students. And that's mostly where we see students wanting to do the dual, to give them more options when they graduate, to get more job prospects. The concern that we have sometimes is that some employers look at it as a watering down 2 degrees to get the dual. And that's really not what we do, because students still have to fulfill the requirements for both degrees. But I think the illusion or the idea is out there, maybe other colleges do give a little more flexibility, and they let, some requirements for one of the degrees kind of go as long as they're doing both. But at least at RPI, you're definitely following both curriculums. There's no shortcuts. There is overlap, but basically that just means that they share requirements. So, it's just that you have to complete the set of aeronautical classes in addition to the set of mechanical classes. The other thing is that you want to have a story behind your dual degree. You want to have a good reason to say that you did it, and don't leave it just at you wanted to keep your options open. Hopefully you have a good story that you have an interest in both areas, or maybe a specific research that you're doing that you found that it would be really helpful to take those extra mechanical classes, and that led you to the dual. Whatever it is, and that's kind of what we help students explore, that the reason is really important, so that when you're talking to an employer, you can say, I was a dual degree because of this reason, not just leave it at that, because employers aren't really that impressed with a dual degree until you get to explain why you do it.
Great, excellent. And actually, another related question. So, would there be any recommendation for co-terminal if someone is pursuing aeronautical and mechanical? Would you recommend a bachelor's of one over the master's of another?
I think it could go either way. I think it's going to depend again on what that student's goals are, probably, and whatever your goal is. Hopefully, that's where you're kind of launching from. So wherever you finish up, if that is an aero, hopefully that's the career path you want to go into. Fotis, do you have anything else to add?
So especially when it comes to co-terminal and the masters, it's about your preferences and your goals and your objectives with respect to the professional career, because it's going to be an opportunity to dive deeper in some of the classes, courses, get some experience. That's going to be very, very significant. So I think the motivation and the interests are the most significant aspects when choosing a master's.
Great. Yeah, and for a couple of folks asking about co-terminal, you don't have to apply to that until your junior year. So as you think about, applying right now, that's not something you would have to apply to right now for, overall admission to RPI. Actually, you can't. It's something you would work with your advisor on, a bit later on in that junior year. And then someone's asking, can you do co-term if you dual major? That would be a lot, but definitely, have you guys seen that? It's definitely possible, for ambitious students.
I've seen this, right? I think so, yeah.
Anything's possible or ancillary.
Yeah,
like a
and
dual major,
I think I addressed this in the chat, but I don't know if I said it out loud. But if you start from the beginning and you plan wisely, and that means, you know, if you're not taking anything outside of the 2 curriculums for an Aero Mech dual, it's really only 2 more credits. But again, what happens is those 12 free electives, you don't have the freedom to choose those. Those are all mechanical classes. So like for a student who wanted to take one management class, they would have 136 because that would be an additional class that's not part of either curriculum. So it's possible. I mean, it could do that, but it would take longer, and it would be busier. And but we definitely have duals that go on for co-terminal, either for one or the other, so aero or mechanical, or something else outside of that too.
Great. Someone asking about percentage of students, women and Hispanic. And so we don't break it down by major. We are 32% women here in engineering on campus, and then 10% Hispanic throughout campus as well. Breaking it down by major, we are a smaller institution. We have about 6,600 undergraduate students overall. So just breaking it down, we don't produce all those numbers by major. And it does change, right? Students, change their interest all the time. And someone's overall asking, how is our aeronautical engineering program just different or unique from others
in the
country?
others?
So,
okay. Please, Kate.
Yeah, I think Fotis, you could probably answer this, and then yeah, go ahead.
Yeah, at least.
Or do you want me to answer it?
If you want to start, please start, and then I can say what is my experience with respect to the other programs that I know.
Yes. And I did want to just mention that what you see, like with me answering some questions and with Fotis answering others, this is very similar to what students experience, because the reason why we have both, why students have advisors that are professional, like myself. This is my job. I advise students. I help them with the procedures and, can you do this? Can you do that? How do you mix it all together? And then we have faculty advisors for students for the questions that are more specific to their field, right? So again, like, how do the programs compare? It kind of overlaps a little bit because Fotis would be in contact with professors from other colleges in engineering, not like I'm not in contact with them. But we do have students that are comparing. So the one thing I will say across the board, RPI is definitely known for students collaborating really well together. We do a lot of group work in our classes. We do a lot of hands-on work. We do a lot of lab work. So students really have those experiences that can carry on to the work, the world of work afterwards. So that's what we're known for. Our students know how to work hard. So that means you're going to work hard when you come to RPI. There's a lot of resources for students. Our admissions requirements are rigorous, but students that come here are successful. We have a great retention rate. So, even though it's hard, students are able to do it. They have the resources they need to be successful. So I think that says a lot in how we compare to other colleges. And then just in terms of what students are doing in the classroom, maybe, smaller classes, more interactions with faculty, more opportunities for research. We touched on that a little earlier, but students as early as freshmen can do research and get credit for it or get paid for it. Not a lot of freshmen, but some. And then the longer you're here, the more opportunities there are for research. I lost my train of thought with that, but a lot of students are interested in doing research on campus. And again, you can actually earn credit. So it doesn't actually have to be something extracurricular. It can be part of your degree. So again, you can use that for your free elective credits. You can use it for your technical elective credits. Or again, you could also get paid if you wanted to go that route. And that was an option. So,
yes.
So I don't know if Fotis wants to talk more about
example, right? In the class of aeronautical students, we have 120 students, right? Let's assume that number. You can imagine the differences between a school where there are 120 students versus a school in which the class is 1,000 students. Right? So you can. I think the differences are evident. Now, one of the great things at RPI is that obviously we're a small school, but it's very easy for all the students to interact with the professors, with the staff, with faculty, in their labs, in their classes. So in my case, in my classes, I know at the end of the semester, I know all the students by their first name. I'm not sure this is possible in schools that are larger. And I'm not talking about the quality. The quality obviously can be equivalent, but I'm talking about the personal characteristics. So this is one of the great advantages at RPI. And when I was in job search and I interviewed for other schools as well, this was probably the main reason why I chose RPI. So it's a very it's a small school, and it's a great environment between the colleagues, students, staff, and everything. So it's very easy to reach out. It's very easy to talk to someone. It's very easy to find and talk to a professor, or like to Kate during office hours. You won't have to wait in line with 50 more students waiting ahead of you. Research opportunities, it's so easy, as Kate mentioned, they're integrated within the curriculum. So if you want to perform some undergraduate research, you just have to reach out, you talk to your professor, lecturer in class, you meet, you decide if you would like to go for credit. We also have paid positions. In my case, I usually have 2 or 3 students, undergraduate students, who are being paid during summer most of the times as internships. And this is very easy because, again, we're a small department. I think we have, again, I don't want to repeat myself, but I see this as a major difference. Now, when it comes to the research areas and the topics, all good universities, all good aeronautical programs, they need to have high-level quality faculty in aerodynamics, in structures, in controls. So this is equivalent. Now, when it comes to the specific areas of expertise of the faculty, again, there are some unique characteristics here at RPI. I'm not sure if this is relevant to an undergraduate student at this point. But again, I don't want to say RPI is better than other schools, but each school might be unique in some of these aspects, okay, when it comes to research and faculty.
Great, thank you so much. Another one, how often does the undergraduate
So I think the curriculum is more like a live organism. It doesn't change very often, no. But when we have the faculty meetings and faculty retreats and staff, we talk with staff, lecturers, and everyone. I think we're trying to, first of all, assess the curriculum, trying to find if there are some issues, what are the current trends in the job market, in the professional environments, in the companies, in the industry. And we're always trying to be in touch with the world outside RPI. So if we ever realize that something has to change, this will happen. I think in the last 3 years, there was only 1 or 2 changes in the curriculum. Kate, I'm not sure if you can confirm if this is the case, but there were discussions about these changes. There were discussions like for at least, I would say, 1 year before they were put forward. So, yeah.
Mm-hmm. Yeah, there was a pretty, probably 3 to 4 classes difference between our now seniors and juniors, the current juniors. So there were changes in terms of certain classes just shifting to a different, format. So it's not just a even swap. So, and then a couple years before that, there was maybe a 1 requirement change, very slight. It went from from a science to a technical. So it's very small, and it was just, yeah. So sometimes there are small changes. The big changes I don't think happen as often, but again, there's always a good reason behind it. So hopefully that answers the question and the reason for the question the student had.
Great. Thank you. I did have a couple questions about the candidate's choice application, which I will take. So applying to Rensselaer, you have 3 different options: the common application, coalition app, or our own application, which is called candidate's choice. You only have to submit 1. You don't have to do all 3 or even 2. So just 1, whatever works with you out of convenience. So we highly recommend that students who attend a Naviance high school to apply using the common application, just because it is easier for your guidance counselor. The transmission of data just works between Naviance and Common App, so that's one recommendation there. But the Candidate's Choice application, we do send out to students who we think would be a good fit for RPI. We've streamlined it just a little bit, so kind of taking out some of those questions that we don't quite need. So if efficiency is what you're after, definitely apply using Candidate's Choice, but they are weighed the same. So there's no true benefit of using one over the other. So that's the deal with Candidate's Choice. And all of the admissions reps for your territory, we actually handle different territories. Mine is Connecticut as well as Southern California, but all of our territories are posted online. I can pop that link in here for you as well. Definitely be in communication with your admissions representative. We're here to help you through the process as well. So as you get started thinking about those applications, feel free to reach out to us. That's what we're here for. And someone else asking, if you apply as a dual major, you only apply to one major. So getting back to that, you would apply to the major, kind of your first and foremost area of interest. So the common application and all of our applications won't have any space to apply into a dual major. You'd declare your dual with your advisor once you get to campus. Someone also asking about visiting. So unfortunately, we are not able to welcome visitors to campus, and that looks like it's going to head into August as well. We are remaining very on top of Governor Cuomo's restrictions here in New York, and we just want everyone to be safe. So it does mean that we're not able to have campus visitors yet. I'll pop in the link for the specific area of our website where we will post updates. So definitely check back on our website, and as soon as it is safe and that we can, we want to have visitors back to campus. And we do have a great virtual tour. Many of you probably have already seen that, but the virtual tour link I will pop in here as well. It's a great intro to RPI. We have a map, but this just takes it one step further, and you're kind of walking around campus, which is pretty stellar. And we do have a great Instagram. I'll just plug our Instagram specifically for admissions. We have a lot of great content. It's at RPI Admissions. Easy to remember, at RPI Admissions. We have student takeovers. We have student groups taking over, faculty members, staff members. There's a lot of great content on there. So that's just another way of seeing RPI, behind the scenes, as opposed to, just walking around campus virtually. And just a couple of questions about kind of music groups. Someone plays the piano, so do I. That's great. You do have great access to over 200 clubs and activities on campus. This year will look a little bit different in terms of social distancing, but those are run out of the student union. Our student union actually is run by students. They manage an $8 million budget for all of our clubs and activities, so plenty of areas to participate in music. There are a lot of great student groups, a cappella groups, dance groups. So there's definitely something for everyone here at RPI to either continue on from when you were, in high school, or to try for the first time. So that it's a really great area to do all of that. And let's see. So kind of a last question here. In the individual and group research projects and coursework, is there time during the week? During the week for the work, or do students usually meet up to work on the weekends? Any insights there as to kind of when students find the time to do everything?
It depends on the students, right? So if it's a student team that is working on a research project, it's up to the team itself and the students to define when they would like to meet and how to allocate the tasks and what the time schedule and management would be. Most of the times, I think students do work during obviously weekdays. Oftentimes they have to spend some time during weekends as well, but it depends. Yeah. I would say both are very common.
Great, thank you. Yeah, so in the interest of time, it looks like we are just at our limit. All of our questions have been answered. I will pop just a few more links in there that I promised everyone. But thank you so much, Fotis and Kate, for your time today. It's so insightful. I know I learned a lot from this, and I know our students are appreciative of your time as well. For anyone else, I will pop in. So I just popped in our counselor territories for admissions. All of our email addresses are there as well, so feel free to reach out to us. Our general admissions box is always manned as well, admissions@rpi.edu. So if you don't know where to start, just email us and we'll be able to direct you. Thank you everyone for your thoughtful questions. I thought this went very well, and we're really, really happy that you're able to join us today. Although it is virtual, we will have plenty of other opportunities as well to connect on a deeper level. We do have some more engineering programs coming up, so definitely check our website for that. And with that, I guess I'll let everyone go.
Thanks for joining us.
Thank you so much again.
Bye.